thanks for the invitation. Thanks for the introduction. Looking forward to this lecture. I can see it is planned for 90 minutes, so I would say there will be definitely plenty of time to have a lot of questions. And yeah, I think I can go directly to the presentation. So what I prepared is I kind of freestyled some Solana program, which I will show you fast tests on. And I have also presentation. I will show you how to install the Trident, what is the Trident documentation, where you can find it. I will briefly show you the repository where the Trident is maintained. And that's it, basically. After the presentation, then we will have the hands-on example. So firstly, let me share my screen so we can start with the presentation. All right. Present. Okay, I think you should see the screen because I see it on the different monitor. So hopefully, guys, you can also see it. So the presentation will be about the art of manually guided fuzzing with the Trident. We received the grant from the Solana Foundation for developing such tool a bunch of it is already months ago. So yeah, that was the initiative. We were aware of this testing technique, also from the Web2 security. It is pretty well established. So we decided that there is a lot of such tooling on the Solana blockchain. So we decided to start developing it. From the different ecosystems, you may know, for example, if some of you guys know Ethereum, then we have also a fuzzing framework there. It is not called Trident, but it is called Wake. And it has a bunch of different also functionalities, such as static analysis, integration testing, etc. Regarding Trident, it is just the fuzzer. Previously, a few years ago, because when we started to develop the Trident, it was integration testing framework. I can remember it was the start of the Solana. It was something like 2022. It was, I think, this year. Everyone was actually developing frameworks for POC tests in Rust and also integration tests in Rust. You may know that Neodyme had its framework. I'm not sure what's the name. We've got our framework, which was previously called Strudelnik, not the Trident. Actually, Strudelnik is Czech word. So yeah, at the time, a lot of people were developing tools for the integration tests, and then we moved forward with the fast tests. I think this is pretty enough from the introduction, so I think I can continue in the presentation. Slightly from my side, I'm the lead auditor at Ackee. I'm also, let's say, lead lecturer at School of Solana. I recorded and prepared a bunch of materials, lessons, tasks in there. On the other hand, there are already a lot of people from our company, a lot of colleagues that maintain this stuff, also record lessons. So yeah, currently I'm lead, but I'm not actually preparing that much materials or lessons anymore, and this will change also in the next cohort, where we will have new lessons, up-to-date lessons with, I don't know, Alpenglow, new topics, etc., etc. So you can definitely look forward to that. You can see my Twitter handle, so feel free to give me follow. If you want to discuss something, I'm open to DMs, so feel free to send me DMs. Please don't send me some spam or phishing or something like that. If you send me some random link, I will not click on that, so no worries. Okay, so regarding the Solana and the Trident, so what is behind Trident? So these are pictures of bunch of DM on Slack or X. Sure, you can DM me also on Slack, because I'm also in the Rectov Slack channel, so definitely you can DM me there. If you DM me on X, that's also all right. And yeah, if you are part of the School of Solana on Discord, you can also DM me there. I think my handle is pretty similar on the Discord, so no worries, no problems. Regarding this slide, the pictures are kind of outdated, but they are still pretty relevant on Solana. But Solana is currently in a better state than the pictures are showing. So what is happening on Solana? The TVL is basically growing, the user base is basically growing. There are more developers, more users, more assets, tokenized assets. That's pretty sound topic for last few months. And yeah, so DeFi on Solana is growing, and for that, basically Solana is becoming internet capital markets. That means a lot of funds, a lot of assets are basically on Solana, and we want, as a security auditors, as security researchers, we definitely want to protect the funds. There are a lot of options how to do that. There are options such as doing perfect audits, or doing the formal verification, or doing the fuzzing, trying to utilizing AI in the security of Solana. So there are a bunch of options how to achieve that. So what I don't want you to take from this lesson is that no, fuzzing is not like perfect approach, but there are a lot of really good approaches, and we believe that fuzzing is one of them, one of the superior ones. Regarding fuzzing, it is not enough. I can still remember the first years of the Solana where integration tests were really powerful, but we are moving with the complexity, with the complexity, we are moving forward with the complexity of smart contracts or programs on Solana. And when the complexity grows, then there are much more edge cases that can basically happen in smart contracts. And for that reason, it is not enough just to write 5, 10, 20 integration tests, but you want to build a pyramid, or all the pillars of sorry, I'm speaking, I'm talking, and at the same time I'm trying to read the questions. So I will try to finish sentences and then read the questions. But I don't have anything against reading and answering questions during the presentation. So yeah, I was talking about the stress testing and growing complexity. So yeah, growing complexity, a lot of edge cases. That means integration tests are not enough. It is not enough to have just 10 integration tests and then audit. It is perfect if you can utilize all of the possible testing scenarios, testing options, integration tests, the fast tests. If you can go with the formal verification, that is also good. And then at the end of the day, the menu review from the auditors, the audit. If your smart contract is perfect, if your testing is perfect, then there should be no issues after the menu review. There was the question. So Trident is similar to what Foundry does with EVM-compatible smart contracts for stress tests. To be honest, I'm not sure about the EVM world, and I'm not sure, I don't know enough about Foundry. If you, on the other hand, know the wake, yeah, Trident is manually guided fuzzer. I will tell more about that. But the wake from the EVM is also manually guided fuzzer. So the principles with Trident and wake are similar. Regarding Foundry, I'm not sure. I was not studying this topic, so yeah, I'm only Solana based because we are Solana Maxis. So no, just kidding. I also think that Ethereum is also good. All right. So for those who don't know what fuzzing is, fuzzing can be basically described with one simple statement. Fuzz testing is a testing technique that provides an important random, valid or invalid or unexpected input data. So instead of your instruction just expecting one number, so instead of testing it with that one number, that particular number that, I don't know, 5 or 10 or something like that, you want to test it with the at best with the whole range of numbers that are supported as let's say instruction input. There are much more techniques that you can utilize during fuzzing. So you can fuzz, for example, instruction sequences, etc. But this is the simple example. If your instruction expects that there is some kind of transfer amount of its on the instruction input, and this transfer amount is unsigned 64, you want to try all of the numbers. Of course, this depends heavily on time and for how long you are fuzzing. Fuzzing is kind of probabilistic technique because you can't cover in, I don't know, 10 seconds, you can't cover all of the cases, all of the numbers. On the other hand, if you have good fuzzer, which can be fast, and if you are fuzzing for great period of time, that means hours, that's possible. That's not that much, or even days, that's also possible. If you run it locally, then in that case, the covered space is increasing drastically. So that means you almost covered everything. All right, for the 64-bit long numbers, I don't have the exact time amount required in my head, but yeah, the success rate basically increases with the time. And what this allows you is to find, for example, the undesired reverse in your smart contracts or different vulnerabilities. When you implement the invariant checks, which currently we have invariant checks in the Rust, but the perfect scenario would be if we can write the fastest in different languages, so we can basically compare the behavior of math, of rounding issues, etc., in different language. Because in Rust, okay, it's still the same language. We can, in the invariants, use, for example, different libraries, and then we can also find issues with the rounding. But the invariants, if you take the invariant and you implement basically exactly the same logic as is in the smart contract, it might be problematic, because if you have issue in that logic, it will not be found by the invariant. On the other hand, this can be really powerful because at the same time, you are reviewing the smart contract and you are comparing the behavior. So for example, for the regression testing, that's pretty useful, because regression testing means you made some changes in the smart contract and you test that the smart contract basically behaves as it was behaving before. Of course, you did not make like logic changes, but you refactored the smart contract or something like that. And in that case, the invariants can be so powerful. I was talking about undesired reverts. So this can happen. For example, you have unwraps. So something like you have some function or some call which returns some or none, and you unwrap on that. And in that case, it can panic on the if the function returns none, and it can cause undesired revert. So the whole transaction will revert. And you may say that, yeah, but it is not a problem because no one steal the funds. But that's kind of true. No one actually, there is no unauthorized access or something like that, but there might be denial of service issue. And denial of service is pretty important issue, because that means, for example, if the funds are locked in the smart contract, even though no one stole the funds, for example, the user is not able to withdraw the funds. So this can be pretty easily critical severity issue. All right, so fuzzing can be really easily and nicely described by this meme. So the tester in a bar offers beers, 1 beer, 2, 3, 88, 0, minus something, he can also order, I don't know, Fox instead of beers. And that's basically fuzzing. I have small note in the down left corner about black box and gray box, because I will be talking about the manually guided fuzzing. And in terms of the black box and gray box, just brief overview. In a black box fuzzing, that means you give the fuzzer, you give the smart contract, and the fuzzer tries basically everything random. So your program expects 10 accounts, and these accounts have some kind of relationship between them. So one is PDA, another one is signer. The account that has PDA, program derived address, the PDA depends on the signer, etc., etc., etc. And these are relationships between the accounts or between the addresses, and the black box fuzzer does not know about them. And all of these relationships, as the fuzzer does not know about them, all of the, or a lot of tests that would the fuzzer produce would fail, because these are pretty strict requirements for the instructions, and just small space is good for the instruction in order for the instruction to be successful. So what would be the finish line for the black box fuzzer is that you would be fuzzing for hours or even days, and as the fuzzer does not know what is the logic, what is the interface to the smart contract, then after the days you would see that the code that the fuzzing coverage is pretty small, because the fuzzer was trying a lot of completely random accounts, completely random instruction parameters, which in principle does not make sense. Gray box fuzzer, this is something between a black box fuzzer and manually guided fuzzer. Gray box fuzzer, for example, has already some kind of knowledge. So in this case, in the context of Solana, the knowledge can be, for example, the interface, so the IDL. So you take the IDL, a gray box fuzzer has a look at the IDL and sees, all right, this account is mutable, this account is signer, there is this relationship between this account and another account, program derived address, etc., etc. So in this case, the fuzzer can generate more suitable data for the smart contract and basically faster achieve good fuzzing coverage. So this is a pretty simple overview. The example is on the Solana, is for the Solana program. So of course, the examples might be slightly different for, I don't know, Web2 fuzzing, etc. Let me drink water. In the manually guided fuzzing, as the name suggests, there is some kind of guidance. So you can see the meme is slightly updated, and there is on Monday, the tester orders 0 beers. On Tuesday, on Monday, because yeah, the tester knows that he shouldn't be drunk on Monday, so he orders 0 beers. On Tuesday, he was already doing some kind of work. He started, so he wants to kind of chill out for a bit, so he orders less than 5 beers, okay? And on Friday, he orders 1, 2, and then 88, because after the second beer, he wants to go all in, so he orders 88 beers. So yeah, there is some kind of guidance from the tester. That's basically the principle of the manually guided fuzzing. You as a developer or you as an auditor have access to the smart contract code, and you can basically see what is the interface, you can see what is the logic, you can see what is the math performed, you can see what is the CPI performed, etc. And based on that, you can include these CPI programs in the testing environment. That means the instruction or the transactions will successfully, because the programs are present in the client, etc., etc. So there is this kind of guidance. Manually guided fuzzing from the Solana POV. I will start with the disadvantages. So it is not that black box. As I said, it requires the guidance. So that means you need to sit down and write the fastest. At this point in time, there is already Solana, there is already AI. I don't know, maybe I was drinking already a few beers, so yeah, maybe that was the start of the idea. Yeah, so disadvantages from the Solana POE. It is not so black box. Why is it disadvantage? You need to write the fast test. On the other hand, at this time there is AI. If you are using cursor, it can drastically reduce the time required for writing the fast test, and it can definitely help you. We have already some ideas in mind how to utilize AI during the fuzzing, so stay tuned to a lot of news from the fuzzing ecosystem on the Solana. But then there are advantages, what we think. It is dedicated to the protocol needs. So yeah, this is the disadvantage, as the disadvantage is that it is not so black box. On the other hand, it can be dedicated to the protocol needs. So you as a developer, or you as the developer of the protocol, you know the important parts of the project, of the protocol, of the source code. You know where is the math. You know what are the you know where are the what are the accounts. You know what are the instruction parameters. So it is really easy for you to write the fastest. Also, it is also what is important are the instruction sequences. The black box, and also, or sorry, from the different perspective. Most of the programs on the Solana work such that there are, let's say, 15 instructions. And sorry, there are a lot of questions and a lot of discussions. The program on the Solana expects some kind of sequence of instructions. What that means? There is initialize at the start of the program, then there is initialize config, initialize user account, then there can be deposits, withdrawals, I don't know, borrow, add liquidity, repay, liquidate, and then at the end, some collect fees, etc., etc. Yeah, I know I'm describing DeFi. DeFi is not only DeFi is not the only part on the Solana. There are a lot of different protocols, but most of the time, I would say 95, 99% of time, there is some flow expected. So some initialize instructions, something in the middle and something in the end. And this is also important because with the black box, if you have 15 instructions, the fuzzer would most of the time, the black box fuzzer would most of the time create also a completely random sequence of instructions. And that means at the start, it would try to withdraw funds, even though the smart contract is not initialized yet. So that does not make sense. So in that case, you use the manual guided fuzzing where you can dedicate to the protocol needs. So if you understand the protocol because and you understand it because you are the developer or you are the auditor, you know that the initialize should be executed first, then the deposit, and then the withdrawal, and then at the end should be the collect fees. Yeah, that's the dedicated to the protocol. It's a point. Covers edge cases. Yeah, as I said, basically the idea is that you are using the whole range of numbers. So from 0 to U64 maximum, or you can utilize stateful fuzzing. In that case, stateful means you can check, all right, this token account has this kind of balance. So try to, instead of transferring all of the amount or zero amount, try to transfer something in the middle, also with boundary values, so also with the zero and the total token amount. And in that case, you transfer or generate numbers from this kind of range. Mimic the real-world environment. This is also important, as I was talking about the CPIs and yeah, basically the mainnet programs, mainnet accounts, etc. In the Trident, you can, even though we have light client utilizing the Solana SVM API, we can basically mimic the real-world environment. So that means you can mock programs from the mainnet, you can mock accounts from the mainnet, and include these accounts into the light client of the Trident SVM. So that means you can use, I don't know, Dexys. You can use Camino in the fuzzing if your program integrates with Camino. You can use the configs that the Camino uses. You can use, I don't know, Marinade, Jupyter, etc. So everything is possible in the Trident, dumping from the mainnet accounts, also programs. Yeah, and yeah, the fuzzing actually does not perform any abstraction, not or nor approximation, but the real behavior. So you are basically executing the instructions, or let's say transactions, if you have multiple instructions within the transaction. So you are basically in the same way with atomicity executing the transactions. All right, about the Trident. So it is pretty simple. It is Rust-based CLI tool. So you install it with cargo install, Trident CLI. I will show you after the presentation. Then there are CLI commands that you can use to initialize the Trident, refresh fastest template, run the fuzzer, debug the fuzzer. There are commands for Trident server, which can be used with the dashboard, etc. The next point is that it generates the template from the IDL. There are already some questions from the foundation, also on the GitHub, in the issues if we support the vanilla Solana. In principle, I can say yes, because in the fuzz test, or what is required for the fuzzing is that you need to write the fuzz test and you need to have deployed the program in the Trident SVM. Deployed program in the Trident SVM. For that, you just need the the Solana SBF. So the binary file that you would normally deploy to the mainnet, you need in the Trident deployed, and this can be that it does not mean if you are using Anchor, there is something different than if you are using vanilla Solana. Of course, the source code is different, but the principle is the same. And yeah, the fastest template is generated from the IDL. So in principle, for vanilla Solana, it is possible, but you will not have the types generated from the IDL. That might be a big issue because the types will help you to create instructions to the program. That's obvious. We have pretty fast execution, I would say. As you will see in the example, the Trident can process thousands of transactions per second. Of course, as I said, it is like a light client. The execution is happening in parallel, but yeah, fast execution. We can achieve millions of transactions within minutes. When we were fuzzing bigger protocols, we could execute this amount of transactions within minutes. On the other hand, it is not about the execution or about the performance as Solana on its own. It is not like we are trying to evaluate what is the TPS of the Trident. It is not that important. It should be fast, but it is not that important if it's 4,000 or 6,000. Yeah, we are not developing any kind of L1. We are developing the fuzzer. So rather correct, not fast. Multiple features to cover real-world environment. As I was saying, you can mimic the mainnet. You can deploy the programs from the mainnet. You can deploy accounts from the mainnet. There is the dashboard. There are the metrics. You can observe what are the logs of the programs, what is happening in the program during the fuzzing. There is also the coverage, which was presented in the VS Code extension, which is presented in the VS Code extension, and yeah, that's about the features. Dashboard, yes, you can basically in the Trident Atomo, you can enable the dashboard, and it will create you this kind of HTML file, which we most of the time use for the debugging, and also if we are performing fuzzing during the audit, we use this dashboard to show the client basically what was happening during the fuzzing. It shows how many transactions were successful, how many were executed, what are the failures, why the transactions are failing, what are the undesired reverts. The Trident also supports some kind of custom metric collection. So that means if you are utilizing the state for fuzzing, and you are not sure from what range the numbers are generated, you can create histograms for basically all of the values, and you can see in the dashboard what is the distribution, what is the entropy of the numbers. A stateful fuzzing, I think I already described this. Basically, you have a look on the accounts that are basically present in the client, and based on that, you generate numbers. So or generate random ranges, random inputs, random accounts, etc. So if there is, instead of generating or using random numbers from 0 to U64 maximum, you can specify that, all right, I want to generate from 0 to token amount in this particular token account. And the invariant checks, you can compare the behavior of your program within the fuzz test. As I said, the fuzz test is written in Rust, so the perfect would be if it is written in different programming language, and you can compare basically the results. as it is written in Rust, there are still options to basically perform the same math logic with different approach. In that case, that's perfect. Okay, this was everything from the presentation. I could see there were a bunch of comments in the chat, so let me how did you get this beer idea, bro? Yeah, I already answered it. Currently, cursor better than Claw or ChatGPT for fuzzing? Good question. I like to use Claude more. I'm not that guy who changes models every day, so I'm using just Claude, and I think it is enough. But yeah, based on benchmarks, maybe GPT might be better. I'm not sure, but I'm just using Claude. Was Trident extension was Trident extension got renamed to Solana in VS Code? Any plans to release this extension for IntelliJ JetBrains? Okay, renamed, no. It was from the beginning Solana. And any plans to release this extension for IntelliJ? Plans, to be honest, no, because I would say most of the people use Cursor or VS Code extension. On the other hand, if it is not like really difficult, we can do that, I think. Perplexity is also good, yeah. Okay. Any other questions so far? Looks like no. Stop sharing. Okay, that was presentation. Now I think we can go to the hands-on example. If you can got it, was thinking if we can use this extension with the Rust drawer. To be honest, I'm not sure what is the Rust drawer because I use Cursor, so I'm not using this extension if it's available in the Cursor. Okay. Okay, what's the time? All right. Oh, we are in a half, in the middle. Okay, let me share again and now. So what is available? So you can see, if you know this web page, it is called crates.io, and you can inspect a lot of different crates there. For example, Trident CLI. Okay, the first thing you popped up is basically the Trident CLI. So if you open it, you can see the versions, dependencies, etc., etc. There is the install command, and there is how to install it as a library, not that important. There is the README from the GitHub. Also, you can read that in the GitHub. What might be important are the versions. Today, I will show you the release candidate. Yes, it was released 2 days ago. There are some breaking changes in the fuzzing template that we are trying to implement for the next release. And yeah, already 16 releases. What I mentioned in the beginning, previously the Trident was called Trident, and it was integration tester. So somewhere in the middle, we changed it from the Trident to the Trident. So yeah, that's one reason why there are a lot of versions. The second reason is that we are actually trying to discover basically what is the best possible option to use this. Previously, we were using the honk fuzz, you may know it, or AFL, from fuzzing the Rust native programs. But we switched from AFL and the honk fuzz into the manual guided fuzzing because it was causing us a lot of issues, a lot of troubles to the developers trying to use the Trident. So we switched to this. On the other hand, we have still plans for the AFL, as I was talking at the start of the presentation about some AI, etc. So we have plans for the AFL and some kind of gray box fuzzing, so stay tuned. This is side note, but there is this dependencies page, and this can be really helpful, not only for the Trident, but side note, also for the Solana crates, because there are a lot of Solana crates. There are Solana crates with version 3 already. Previously, there were with version 2. So if you are not sure about some of the crates in the Solana ecosystem, what are the dependencies? You can see all of the dependencies here. also for the Solana crates, and you can evaluate based on that if the crates are compatible or not. So this might be helpful. All right, let me skip to the release candidate. Maybe I'm not sure if you are familiar with the pre-release versions in the Rust, in the crates.io. In principle, you can have also pre-release versions with the Rust crates. And in this case, it is called, for example, the release candidate. There are more options than just the release candidate, but we just stick to the RC, which stands for release candidate point one. What it means, if you let me go to the released version, the last released version, and if you, or let me, give me a second. One more second. Yeah, you can see it here. So if you open just the Trident CLI page, you can see that there is no version. So if you specify this command, cargo install Trident CLI, it will install the latest released version. If you want to try the pre-release, the release candidate, you need to specify cargo install Trident CLI bit the version. So 0.12.0 dash RC1. Just for you to have an idea. Maybe most of you already know this. Okay, let me go to the different page that I would like to share, and that is this thing. So we have the documentation. We try to update everything important there. You can go to the maybe where you can find the documentation. So it is this page. I will post it in the chat. And yeah, we have the documentation which we try to maintain for all of the releases. What is not released is here in the dev branch, basically. So for the release candidates, for the pre-release versions, you can navigate to this dev version, the dev branch, and you can see a bunch of stuff, how to install the Trident, how to start fuzzing, what are the advanced options, such as invariance flows, what is the API. We call it Trident API reference, but it is just the functionality of the Trident SVM client. There is manifest, there is Trident SVM, which does not contain much information, but it contains a link that we use the ANSA's SVM API and GitHub repository of the Trident SVM. For those who don't know, I forgot to mention, Trident SVM is something like Light SVM. I wouldn't compare it one-to-one on its functionality, because I would say Light SVM is much more complex. On the other hand, it is something similar, so Light client, basically. And examples and also pipelines. So what we have implemented in the Trident repository are the pipelines, which you can use also when you are writing the Solana programs and you want to have fuzzing pipelines, which can be which are run on the GitHub. You can definitely take it from the Trident repository. That's about documentation. Of course, we are people, we are not robots. There might be issues or bugs within the documentation. So feel free to open pull requests if you want. You will be collaborator on the Trident in the Trident repository. Okay, back to the meeting. The last thing that I want to show you before we will go to the example is the repository on, and it is under Ackee blockchain, and it is Trident repository. So basically, there's everything. If you open the actions, you can contribute to Trident documentation as well. Sure, I can briefly via GitHub. Sure, because if you open pull request into the develop, in that case, when the pull request is merged, we have this pipeline, which is, I think, build documentation, and it will build the documentation and push it into the into this documentation branch. All right, don't create pull requests into this branch. All right, this branch contains automatically built stuff that is merged into the develop, and from this page, from this branch, it is automatically taken and updated. The front end is updated. So yes, you can collaborate also to the documentation. Yeah, basically what you can find in this repository. Let me skip to the develop, but it is the same as the master. You can see the rates. All right. Then there are cursor rules. Currently there are rules just for the documentation. This is just the intro for the rules for the documentation. So there definitely will be changes to these rules. What I would like to see is that to have also rules for writing the fastest. That would be really nice. Then there is the documentation folder. Here you can update the docs. And here is folder with the examples. So CPI, simple hello world, some internal ideal testing, then tests with the Metaplex. Recently we added also tests with the token for the token, SPL token and token 2022 program. And there is Trident benchmark. This Trident benchmark is program taken, I think, from the Ethereum ecosystem. I'm not sure what's the name of the program. It has some name. I'm not really sure. But for that, we were developing the benchmark and testing our Trident on this kind of benchmark. Yeah, I don't have a table with the results, but the results were pretty nice. And yeah, I think that's basically everything important. Maybe one important thing might be if you want to install the Trident from the repository, there is makefile. So you just clone the repository, navigate to the branch, I don't know, develop master, and you can run the make install, and it will automatically install the CLI and install the Trident as the CLI tool from the repository. So once again, make install. Of course, there are also different make commands. And yeah, this page is the same what is on the crates.io. Okay, everything from the repository. Before I move to the project that I vibe coded freestyled before the lecture, are there any questions? Maybe there were some messages in the chat. Yeah, how can we contribute to Trident documentation as well? Yes, I answered that. Fuzzing, you see it's something someone can master it like menu auditing, or is it that something about knowing what to know fast and take the time to run it? Like something that does not test someone's skill that yeah, like brute forcing arguments or fuzzing for subdomains on Web2. Yeah, give me a second. I need to think about the answer. I think the best way how to approach fuzzing is to, as a it's a big question you have to do. Yeah, sure. I wouldn't say it is like can master it like menu auditing. Menu auditing is basically a lot about the skill. So it is a lot about knowing what are the protocols about, what are the projects about, understand the DEXs, understand the lending markets, etc. So for menu auditing, this is the I think this is the important part to know on one hand side to know what are the common like vulnerabilities on Solana, of course, but there are of course happening uncommon vulnerabilities on Solana. That's the first thing. Second thing, understand how automated market makers, how lending protocols work, how I don't know gaming work on the Solana, all of this stuff, how it works, and that can definitely improve you the menu auditing. In the fuzzing, I think the main principle of the fuzzing is just like a pillar to the security. So my point of view is that the audit is always at the top, but with all of these pillars under the top, you can support the security of the smart contract. So far, right now, at this point of time, I think there is this menu review, which is the strongest one. Then under that, there are all of the different techniques that you can use, unit tests, integration tests, fuzzing, formal verification, some AI auditing, etc. But the manual audits are on the top. If you can, on the other hand, if you understand the fuzzing, if you understand the Trident, of course, it can help you to focus on some stuff. What is also important is that it can give you really easily proof of concept test. So if you see as an auditor, if you see, or during the contest, for example, if you see that there might be an issue with this kind of edge cases, the fuzzing can give you really easily POC test, I would say. Okay, hopefully this answered the question. Now, what I prepared for, yes, thanks, no problem. What I prepared, I like the questions, I like the discussions about the security. So guys, if you have questions, feel free to ask. I'm definitely open to discussions. Okay, nice. You see the of example. That's what you should see. Let me close this. No, I don't want update yet. Yeah, I was definitely testing, all right? So there is already Trident tests folder. I will comment it as backup. And okay, firstly, we can go slightly through the program. So what it is doing. So there is this, we have 40 minutes, right? Here are the instructions of the program. And you can see we have the initialize, we have deposit, we have withdraw, and we have withdraw and close. This is just my example, all right? So I created the issues within the program by myself, so don't try to find any kind of super important and difficult protocol in it. It was wipe coded and prepared by myself this morning. If we go to the process initialize, the logic is that there is the user who is the signer, there is the treasury account, we can go to the treasury account and we can see it has kind of authority, amount, and there is the bump stored. The user is the payer and there are the seats, so simple static, and the user pub key is the seat. Then there is the treasury token account, which is associated token account. It is tied to the mint that is on the input. It is initialized. The payer is again the user. There is the authority, which will be the treasury. And there is the token program from the input. As you can see, here is interface account. So we support SPL and token 2022 for the means token account. And there is interface for the token program. So again, SPL token 2022. And last but not least, system and associated token programs on the input required for the initialization of associated token account and the treasury. What we do in the initialize, we store the authority as the user, amount is 0, and store the bump simple message at the beginning. Let me go back to the main file. Then there is deposit. Deposit is self-explanatory, I would say. So the user, who is the signer, is used here in the PDA, deposits funds to the treasury. On the input, we expect that this account is already initialized because it was initialized in the initialize instruction. And there is the treasury token account and his token account and required mint and also program. Also notice interface account and interface program. What we do in the instruction body, we just take the amount from the input, transfer it from the user, or okay, sorry, we initialize the context, then we transfer it from the user, and then we update the treasury contents here. So yeah, in the treasury account, we update the amount which was deposited. If I go back, then there is withdraw. Withdraw has pretty similar context. User token account, in this case, it will be destination. Then we have treasury token account, which is the source. Again, user is withdrawing here in the PDA. So from his treasury, user is the signer, token program, everything is interface account. In the body, instruction accepts amount. We take the treasury, we check what is the amount in the treasury. If the user is trying to withdraw more than the amount in the treasury, we just round it to the amount stored in the treasury. And if it's less, then we just take the amount that is from the input. If the amount is more than 0, we basically create the transfer check instruction, we execute it, and we update the amount that the user withdraw. And last instruction is the withdraw and close. So context, the same as withdraw with small difference, and that is this treasury is closed. And also here in the body, what we do is that we take the withdrawable amount that we take from the. Can you share this repo? It is not public yet, but yeah, I have plans to push it to the GitHub after the meeting, so I will share it in the Rectov Slack channel. Yeah, withdrawable amount, and we take the withdrawable amount from the treasury account. If the withdrawable amount is more than 0, then we transfer out this withdrawable amount from the treasury account to the user, and then we close the treasury account, treasury token account. Why this withdrawal? You most likely know that you cannot close token accounts if there is non-zero balance in the token account. So you need to first withdraw funds out, then close the token account. Okay, intro to the program done. I don't have coffee, no problem. Okay, now to initialize the fastest. Before I go to the initialization, let me install the pre-release version. So let me click on this. It will be copied to the clipboard, and let me install Trident CLI with a specific version. You can see I have already installed this version, so it was pretty fast. Yeah, that's it. So you can install the pre-release. Now, Trident version, you can see we are using the pre-release version. I have commented out the Trident tests. So what you can do now, or first thing, we can check if we can build a project. Okay, I can write. We can build a project. That is really nice. In that case, we can initialize the Trident tests. So Trident init, if I'm fast, okay, we call the anchor build. Everything is all right. We call the Trident init. Under the hood, what Trident init does is that it builds the anchor project again, but you can skip it with skip build and reads the IDL from the target repository. Target directory. All right, and there is quick how to. Yeah, and this reminds me that I did not update this how to before we release the release candidate. So we need to do that definitely in the future for the new release. Okay. Trident tests initialized. Okay. Now, what is the structure? This is the main structure, test fast.rs, and here is the main. That's the starting point. and we have fastest new with two numbers, 1000 and 100. Now I would like to describe you what are these two numbers, and if you can remember, somewhere in the start of the lesson, I was talking about the sequences of instructions. What are the options that you can fast? What are the options or approaches that you can fast within your smart contract? So the first option, the simplest one, is that you can specify, you can fast the instruction parameters, instruction arguments. So if we have a look into the program its own deposit, you can fast this amount. So what amount you want to deposit, all right? That's the first thing you can fast. The second thing you can fast are the accounts that you are using or you are sending to the program. So if I go again to the deposit, you can try to use, for example, signer, but you will not use his associated token account, but different associated token account. Same goes with the treasury. You can try to pass with the correct treasury token account or with the incorrect and observe the behavior. Same goes with the treasury. In this case, if you write it correctly, you should come to the conclusion that fuzzing accounts is not that does not reveal any issues because you correctly implemented that the user should be the signer. This treasury is tied to the user. In this case, it is enforced by the seed. And as there are unique treasuries for the users, this associated token account can be only one because it is associated token account. It has a program derived address from this treasury and is mint. And this treasury will be unique for a particular user. That's fuzzing the accounts. And the third approach that you can fuzz are the sequences of instructions that you execute within your program. What it means? When you write the integration tests, what you test is that you initialize the smart contract, then you deposit some amount, then you withdraw some amount, and maybe then you deposit again, and then you withdraw and close. And this is your integration test. On the other hand, with the fuzzing, you have, okay, I have initialized at the start, and what happens if I initialize again? What happens if I deposit and then deposit 20 times after this deposit? That's the first scenario. The second scenario might be, all right, I don't have initialize, I have just withdraw. And what happens if I withdraw first? And the third scenario might be, all right, what if I deposit first? And that's the idea of fuzzing the instructions. So instead of just testing within the integration test, testing this happy path or maybe one to unhappy paths, you can have these instruction sequences, then you try to test. And that's where the flows are really handy, all right? So these two numbers are iterations and flows. This first mean like run me 1000 fastest. This second number means that run me 1000 fastest, but in each fastest have 100 flows. And flows are specified with this decorator, flow. Flow, and there is end, and there is init. The idea behind flows is that you can see that you can have multiple methods decorated as flow. And if you have two methods, that means each iteration here from the 1000 will have 100 flows, but completely unique sequence. So the first iteration will have, I didn't talk about the init and the end, but it is pretty simple. I will tell you the whole workflow of each iteration now. So the first iteration will be this start function, which is decorated as init. There can be only one start function that will be executed at the start of each iteration. Then you will have random sequence of 100 flow methods. So for the first iteration, it can be flow 1, flow 1, flow 1, flow 1, flow 2, flow 2, flow 1, and again 100 times. For the second iteration, it can start with flow 2, then 25 times flow 2, and then flow 1. What is important here is that by default, if you have two flows, it is 50% chance, all right? So if you have 100 flows for the iteration, there is 50% chance that this flow will be executed at some position, and this flow will be executed at the same position. So in principle, if you have 100 flows, most likely there will be 50 execution of flow 1 and 50 execution of flow 2. There is also option to increase the weight of the flow. So what you can do is to specify something like this, but the sum of the weights needs to be 100. So in this case, you would need to specify 10 and 90. That means for 100 flows, this flow 1 will be executed 10 times, this flow 2 90 times. Keep in mind that it does not mean like flow 1 will be executed 10 times at the beginning and then remaining 90 times will be flow 2. No. During 100 executions, 10 of them will be flow 1 and 90 of them will be flow 2 at some random position. Okay. And then at the end, there will be executed this end method, or this method decorated with end. So why is it useful? As I was talking about at the start with the instruction sequences, you expect that there is going to be some kind of initialization, some logic in between, and then some claim fees, withdraw, I don't know, terminate user, etc. So at the start, it is expected that you initialize. Okay, and yeah, I forgot to mention, sorry, each iteration has clear state, all right? Sorry, each iteration has clear state. That means at the start of each iteration, it is like if you reset the client. So at the start of first iteration, there are no accounts, nothing. At the start of the second iteration, there are no accounts, nothing. At the start of fifth iteration, no accounts, nothing. So it has reset state. So it is something like if you run 10, if you run thousands of iterations of completely fresh, let's say, integration tests. So at the start, which is the first method executed within the iteration, you execute you perform the initialization. You create a token account if you want. You create a mint. You airdrop. Yeah, that's basically it. You perform the initialization. Then in the flows, what is the best approach so far is that if you have instruction per flow. So our program has initialize, deposit, withdraw, and close. So what I would expect is that within start, you have the initialize, you prepare the mains, the token accounts. Within flow 1, you have the withdraw. Within flow 2, you have within flow 1, yeah, you can have the withdraw. Within flow 2, you have the deposit, and inside the end, you have the withdraw and close. As I said, and it is nice that as I said, flow 1 can contain withdraw, because I want to point out that, as I said, the sequence is not important here, because sometimes the flow 1 will be selected first. Can I add? Yeah. Sometimes the flow 1 will be executed first. Sometimes the flow 2 will be executed first. If you can add new flows, of course, you can just copy this thing and do this, all right? But of course, these are methods, so you need to rename them to flow 3, 4, etc. What is mandatory is init and okay, and is not mandatory. And also flows are not mandatory. You can, of course, perform everything in start. And to be honest, I was not testing what happens if you remove also start, but you don't need to actually have flows. It is not that important, because, all right, sometimes you don't need to fuzz the instruction sequence, or you don't want to fuzz the instruction sequence. So in that case, just put everything in the start, if that makes sense. Okay, I will answer some of the questions. Can I add more flows as needed? Yeah, I answered that. There is an option to make it continue between instructions or put an order for the flows like flow 1, flow 2, then 3 instead of complete restart each time. I maybe give me reason for that because the restart between iterations is important to always start with the fresh state. As I said, if you have the initialize within the start method, you need to of course have reset its state, because if you perform initialize in the first iteration and the second iteration already has initialized, in this case the second iteration has already initialized tree. In that case, the fuzzing will fail on the in the start because the treasure is already initialized in the second iteration. So that's why the reset is important. There was a second question: output an order for the flows like flow 1, flow 2, then 3. Maybe again, give me a reason for that, because of course you can do sequential things within the particular method. So if you want to do something sequentially without the randomness of the flows, just put everything in the start. Okay. The flows get executed sequentially. The flows, yes, but they have okay. In parallel, this 1000 of iterations is split into multiple threads. So there are multiple threads and fuzzing is happening in parallel. If there are available 12 threads, 1000 is split into 12 threads. So that's how many? 80. Yeah, 80 iterations per thread. So that's parallel. But flows in this sense are executed sequentially. So within each iteration, the random sequence. So flow 1, flow 2, flow 2, flow 1, etc., until the 100. I mean, yeah, sure. I will show the fastest. I mean, I just want to explain the logic, but yeah, of course, I will show the fastest. And I wanted to write the fastest from scratch, but I see we are running out of time, so I will just show the final fastest after I respond to this question. I mean, have both, but make it optional, sequential, and also reset option. Okay, if you I'm one, of course, to the contribution. I just don't see yet the use case. But if you have the use case, feel free to open the pull request, write in the pull request why you think it is important, and yeah, we might merge it if you can see the use case. I so far can't see the use case. Sorry. Sure. All right. Now, let me remove this. I think I commented enough about this stuff. Let me go to the prepared fast tests, and yeah, what is kind of unfortunate is that in the cargo toml of the fast tests, this is workspace. The fast tests have its own workspace to not mix dependencies with the program with the program that you are fuzzing. So for this reason, we have this workspace. So what that means, you need to open the fast test in the different window, and the workspace needs to be the Trident tests. Okay, why is this red? Because I removed it. I think I can remove this thing, and this is how the fast test has generated cargo toml. What was not generated is this token, the features. The features can be found in the documentation. There are features for the token. There are features for the vote account, for the stake account. And I think that's all. Why for the vote and for the stake? Someone a few months ago wanted to add a stake and a vote functionality. I think it was someone from the Marinade. So yeah, we basically merged the functionality and added the stake and vote. Regarding the token, this will allow you to call methods or functions for the token 2022 or the SPO token, initialize, means to, etc. This fuzz artifact is empty. It is generated during the fuzzing because it contains some of the artifacts of the fuzzing. I will show you later if I will have time. What is generated also is this Trident TOML. This is something like config file where you can specify which programs to include, which accounts to include. This is pretty similar to the anchor.toml, where you specify, of course, not all of the options are here the same, but as you specify in the anchor.toml, which file, which accounts to include, which programs to include, the same thing you will do there. So if you want to, by default, this is by default specified. So the build program with the anchor build is included within the fuzzing environment with this fuzz programs setup, where you have the address and the program. And I think we have some options, something like update authority, so you can also add update authority there for the program. But please, I'm not sure with that because I would need to check the documentation. And yeah, just the path to the binary file. What we would like to implement here is the fork testing. So instead of you dumping the programs manually from the mainnet, the best thing would be if you just specify address in the Trident TOML, and basically everything will be automatically fetched from the mainnet. That would be perfect. The perfect would be if you don't need to even specify the address, and if the program or the account is not present in the Trident SVN, then it will be automatically forked from the mainnet or devnet. You just select the cluster. That would be perfect. Trident.toml, okay. And there is the fuzz0. If I add new fuzz test, there will be just added fuzz0 or fuzz1, and basically empty as I showed you recently. Okay, fuzz0. Let's go to the test fuzz. So the beginning, you understand. Now let's go to the okay, I can comment on the new method. Just create the default instance of the Trident. This will automatically, everything will automatically handle the deployment of the program. So default Trident, default fast accounts. I was not talking about the fast accounts. Okay. I was talking about the fuzzing instruction sequences and fuzzing accounts, mixing different accounts and fuzzing flows. What we found useful, and this is also kind of from the Solana perspective, but we had also feedback from the Ethereum world with the Wake. We have these storages, and we can call them account addresses. If we go to the fuzz accounts.rs, for the each account, unique account present in the IDL, we automatically create this. Okay, so it might be also for programs, system program, etc., where it is not useful. But for example, for the user, the treasury, the token accounts, etc. Sorry, guys, it is useful. Why is it useful? What you can do is that on the fast accounts, you have this user, as I said, for each account present in the IDL, for each unique one. You have generated field in the account addresses, and you can insert random address to the storage. So what will this do here is that it will insert random address to this storage, random one. If you run this insert in a for loop 10 times, it will insert 10 random addresses to the address storage. Then what you can do, what is opposite of the insert, is this get. Let's see here for the user get. That means from all of the users in this storage, get me random one. Why is it important? Because as I said, if you want to pass the access control at the beginning, you can insert in the for loop 10 times, 20 times, 5 times, whatever you want. That means in that user storage, you push or you insert 5, 10, 20 addresses, but just for the one address, you initialize the treasury, etc. And then if you get if you call the get, it will obtain a random address from the storage. it will not obtain, sometimes it will, but not all of the times it will obtain the correct one for which the treasury was initialized. So if you have 5 addresses, there is, and for one address, you initialize the treasury. For one user, you initialize the treasury. There is 20% chance that this get will pick the right one. And if you want to fuzz the accounts, if you want to fuzz the access control, for the remaining 80% of time, you should see that the transaction is failing. And with the invariant checks, and with the result that the instructions, or with the result that the Trident is returning during the transaction is, or instruction is processed, you can check, you can look into the result and check if it's expected. So in this case, it should be something like, you could see that we were initializing the treasury and there is the deposit. And if we don't initialize the treasury for some particular user, the deposit should fail. Based on the order of the accounts, it should fail somewhere. I think here on the treasury, because for this user, the treasury is not initialized yet, basically. So in that case, you need to check the result of the process transaction after it was executed. What is kind of difficult here is the transaction errors. So because you have transaction error, which includes, I think it is instruction error or something like that. And within the instruction error, you have the custom error. And if the seeds don't match, there is some particular number within anchor for this type of error where seeds don't match, I think. So you basically need to check for this particular number that is happening during the transaction failing. Okay, but let's go to the start. Hopefully you understand the storages. So what we do here is that we insert to the user storage. The first argument is mutable reference to the Trident. It is important because Trident has RNG within. So for that, the second parameter is option, which are PDA seeds. So you can insert the PDAs, but you can, if this is none, you will insert just the empty wallet basically. Then we perform the airdrop to the user, this time 100 SOL. Then we create, you can see, basically, we are inserting into the treasury, we are inserting the PDA into the treasury account storage. So PDA seed, new, the correct PDA, and program ID, of course. Then we want to initialize the mint because, as you remember, there is this initialize and it contains mint on the input. 5 minutes, all right. And there is interface. So we can initialize SPL and we can initialize also token 2022. So, okay, let's initialize token 2022 mint. So with the token feature that I showed you in the cargo.toml, here in the token, you can call this initialize mint 2022. You specify on what address you want to initialize it. You can specify how many decimals. So most common, I would say 9. You specify who is the mint authority, so the user. The fourth parameter is the freeze authority, so in this case, none. And what is pretty nice in this release candidate, you can specify mint extensions. We added functionality such that you can add, basically we are not trying to limit anything in the Trident. So there are mint extensions which are not compatible, but still the Trident will try to initialize them. What we do under the hood in the initialize mint is that we basically execute initialize transactions for the mint with the extensions, and we just let the token 2022 program do its own thing. So if the transaction is reverted, that's completely up to token 2022 program. But you can see, you can initialize mint with the transfer fee config. That can be pretty useful. You can test permanent delegate, transfer hooks, etc. All of the available mint and token account extensions. Then we check the result of the transaction. What is helpful here is that this initialize mint, and also for the instruction processing, the Trident returns transaction result. So if I go to the transaction result within Trident, you can see the first thing is result. So that is the result uh, if it's transaction error or if it's awk. And the second thing are the logs. So if there is transaction error, you can take the logs and you can print out the logs and see what is happening within the program, helpful for the debugging. But in this case, yeah, you can see we check if the result is success. If no, we just take the logs and print them to the output and see what is happening within the program. Then we initialize associated token account, etc., etc. And yeah, maybe what is important, how to execute the instructions of the program. And this is the latest change in the release candidate. We don't want to do difficult things within Trident. We try to mimic stuff, let's say, from the anchor. So this is pretty similar to anchor. Initialize instruction. This instruction is basically, this struct is from the types.rs. This types.rs, you may know that also anchor generates types.typescript or something like that, and the ideal. So these types.rs are pretty similar to that. So you just take the initialize instruction. It has its method data. So maybe in the anchor, in the TypeScript tests, the order is not important. I'm not sure now. Here, the order is important. So you first call this you first call this data method on the initialize instruction, where you specify initialize instruction data. This instruction does not have any instruction parameters on the input, so this new is empty. Then dot accounts, and you specify initialize instruction accounts. These types are from the types.rs. And there you specify all of the required account addresses. What is on the input are the pub keys. You don't need to specify the whole account metas, because if the account is writable or if the account is signer is taken from the IDL. Same goes for the system program. You can see that we don't have within the initialize, we don't have the system program, we don't have the associated token program. Why? Because these are constant addresses. On the other hand, token interface are two possible programs. So in that case, you need to specify the program. Once you have this, you just call dot instruction, which will return instruction type, common Solana SDK instruction type. You just take this instruction and call self Trident process transaction, and here is array of instructions. This is important because in some cases you may want to execute multiple instructions within one transaction. So in that case, if you want to execute 5 initialized instructions, or let's say 3, you will do this. And the last thing is the initialize, is the string, it's the name, how it will be logged to the output if you have turned on the metrics. Fuzz metrics enabled true. So if you have this fuzz metrics enabled true, which is by default, this will be the table that is created. I think I can see we run out of time, so I'm sorry, but this is everything from the description of the fuzz test. I will push the source code to the GitHub repository. I just want to run the fuzz test for you to see how it works. But I will push the source code to the repository. I will be available in the Rectov Slack channel, so you can also on Discord, also on the X. Feel free to DM me, and you can basically use this fuzz test as guidance. So Trident fuzz, run fuzz 0, enter. It is fuzzing, and what we can see here. Okay. We were fuzzing, this is 100,000. Why 100,000 of executions? Because it is 10,000 iterations. Each iteration has 10 flows. So this is 100,000. within each flow we have one. Give me a second. Yeah, this is this 100,000 is taken as 10,000 times 10. Okay, so this is not transactions per second. This is just I would say flows per second. And yeah, flows per second. You can see we are executing 4 transactions, and it was running for 1 second. So yeah, this is approximately 100,000 of transactions in 1 second. I think that's pretty nice performance. Of course, I can add 1 0 to that. And okay, we are out of time. I don't want to show that, but you can try. It will not be that long. The table. I told you that there is this parameter called name for the process transaction, this initialize. So you can see the initialize is here. So basically the name tells you under which name store the metrics. You can see the initialize is here. And for that, we executed 10,000 of times the initialize. Here, 10,000 of times it was successful. Why? Because we were not fuzzing any instruction parameters. We were not mixing any accounts. We wanted to initialize the treasury. If you want to focus on that, of fuzzing the initialize, of course, you can add, basically you would be able to initialize treasury for every user. So there is not much thing to fuzz in the one single instruction initialize. Maybe you can fuzz insufficient funds for the account creation. Instruction failed. This is useful for you to see how many times the instruction failed. And instruction panics, these are undesired reverts. So the instruction reverted, which can, at the end of the day, cause the denial of service for the user. Okay. Pass artifacts. If I turn this JSON to the true and I run it again, okay, I specified, I left the number there. If you have any questions, just ask now. I read the, oh, sorry, there are questions. Didn't learn how to use Trident at all. I see, sorry. I should definitely spend more time on writing the fastest. Does Trident use the Solana test validator? No. Under the hood, also, can I write normal tests using Trident? Sure. Basically, if you specify everything within the start and you specify constant numbers on the instruction inputs, sure. There is well-written documentation, I believe. Yeah, feedback is well appreciated. If you think that anything should be improved in the documentation, I read the documentation previously. The examples were either too simple, I understand, too difficult, which I can't learn how to use. I believe, we can see already the results. I believe the new release candidate should be really easy to understand because it is really similar to the Anchor framework and the TypeScript tests. However, there are the flows, so you kind of need to understand the flows. But if you understand the flows, I think it is understandable and it is pretty easy to write the fastest. But look, this type of functionality where you basically call where it was initialize mint 2022, guys, this is really simple. You just basically, under the hood, the Trident creates the instruction for the mint initialization, and you just need to specify the parameters for the mint. So the address where you want to initialize the mint, the decimal places, the user, the mint authority, the freeze authority, and if there should be any extensions. Of course, this can be like this. So empty extensions. You can also specify just initialize mint, which will use the SPO token, so the older version. And this is initialization. It is the same as within the Anchor where you call, I think it is called create mint or something like that. So that's it. I read, okay. Trident helps for formal verification /test as well. I'm not sure what means the /test as well, But no, Trident is with the formal verification. Formal verification is different approach than the fuzzing. Okay, and regarding the I specified the JSON as true. So within the fuzz artifacts, there is the JSON where you can inspect the data. And last thing, this the data. I mean, these are also results from the fuzzing. If there are transaction panics or errors, you would able to see them there. And maybe also the dashboard. Last thing, HTML equals true. Let me decrease this. Let me incorrect program ID. Yeah, because I changed this thing. Okay, new window, Trident server. There should be file. Where it is? Yeah, sorry, it is not HTML. It is dashboard. Yeah, finally, HTML is there. View dashboard. This is locally, all right, guys. So this is not deployed anywhere, not public. And you can see total transactions, successful, failed, panic. There are issues in the program that I wrote with the transfer fees, but I had no time to show you the issues and the fuzzing. And if the transactions return any kind of errors, you can see it here in the error details, and you can expect